first statement says that EB is congruent to BG. So there is no B on there. Where do you think B is going to be? In the middle. That means I need to draw in some diagonals. They're going to intersect right here. We'll call that B as in boy. And EB is congruent to BG, so I'm going to put a tick mark and a tick mark. That diagonal is now bisected, right? If that diagonal is bisected, what condition does that prove? It's not on today's list. No, it's on the other day's list. What did the other day's list prove? Yes, parallelogram. It proves that it's a parallelogram. Okay, so the first piece of information lets us know it's a parallelogram. That's a good start, right? Because we got a lot of information here. We need to get all that onto there and label it the best we can. Okay, now the next statement says that EB is congruent to BH. So EB we've already marked with a single tick. So let's go over to BH and give it a single tick as well. Okay. That gets us a little more information, but let's see what else we can get. Okay, EG, so here's EG, that's this whole diagonal, we'll call it diagonal 1, is congruent to FH. This whole diagonal, we'll call it diagonal 2. These two diagonals are congruent. Okay, so if the two diagonals, diagonal 1, congruent to diagonal 2, does that prove anything? Look on the list. Does it prove rectangle, rhombus, or square?
Rectangle.
Rectangle, right? Under rectangle, the second condition is that if the diagonals are congruent, then yes, we've got a rectangle. Check. So we've got parallelogram, we've got rectangle. We just need one more thing to get us to square, right? It needs to also be a what? Rhombus. Okay. So we've got a couple more statements here, right? Or no, one more statement. The last one says triangle EBF. So here's EBF is congruent to EBH. So if this triangle is congruent to this triangle, then do you remember this little thing from last semester called CPCTC?
No.
Corresponding parts of congruent triangles are congruent. So I'm going to mark this side right here, congruent to this side right here, side EF, congruent to side FH, because they're corresponding parts of congruent triangles.
One pair of congruent sides.
Right, if we have one pair of consecutive congruent, consecutive sides congruent, we'll say that HE is congruent to EF, and that one was under what? Rhombus. So we've got parallelogram, we've got rectangle, we've got rhombus. So guess what? We can say yes, it is a square, and we are good to go. All right, finish copying that down.